It's Geometry NS Section 1.2, Measuring Angles. Our learning goal for this section is to label, define, and measure angles. And the way we're going to achieve this is by identifying and defining some angle properties. We're going to identify the different types of angles, and we're going to learn how to measure angles. And so we're going to go ahead and start with some basic vocabulary for this section. And our first term is angles. An angle is a geometric figure that is formed by two distinct rays. So if you recall what a ray is from our previous lesson, you remember it will look something like this. And notice that these distinct rays, they have one point in common, which is that starting point. And in angles, this point has a special name that is referred to as the vertex. So as you can see on the left column, the vertex is just the common point that is shared between the two rays. And just like any other point, we can label this vertex with a capital letter. And finally, the two rays that make up our angle are going to be known as the sides of our angle. And that's basically what makes up an angle. And the way we're going to name angles, there's actually two approaches that we can use. And the first way we can use is just name the angle using the letter that corresponds to the vertex point. So here our vertex is A, and so we can simply call this angle A. However, this naming convention only works if the vertex isn't shared with another angle. So for example, if I have more than two rays touching a vertex, then I would not be able to use this naming convention for the diagram that you see now. If you have something like this happening, and I just call this angle S, you wouldn't necessarily know which of the two angles you're talking about. So to avoid this problem, we're going to label a few more points on our angle. And if you recall, you can name these points whatever you'd like. And now I can name each of these two angles something different. So for this red angle, I can use the 3 points as long as the vertex S is the letter in the middle. So for our red angle, we can call that angle XSY, or we could also call it YSX, again, as long as your vertex is in the middle. And in a similar way for our green angle here, we can call that angle YSW, or we can call that WSY. So we can go either direction, forward or backward, as long as that vertex is in the middle. And that basically covers how to name an angle. And the next term we have for this section is a right angle. As you can see in the definition here, a right angle is an angle that measures exactly 90 degrees. And an example of a right angle can look something like this, a little bit like a very straight L shape. And a lot of the time, right angles will also have the little box in the corner there to indicate that it is in fact a right angle. And similarly, we can go ahead and label a few points on this angle, maybe just ABC. And just like we saw before, one proper way to name this angle would be angle ABC. Or we could also call it angle CBA, again, as long as our vertex is the point in the middle. Or for this example specifically, since our vertex B only has two rays, we could also simply call this angle B. Either of those three names would be perfectly suitable for our diagram. So our next term is an acute angle. Acute angles are just angles that measure in between 0 and 90 degrees. So in a sense, they are smaller than right angles. Notice that it has to be less than 90. It can't equal 90. Otherwise, it would be a right angle. And it also has to be larger than 0, otherwise there wouldn't be an angle in general. And so an acute angle might look something like this, a little bit more closed in as opposed to the 90-degree right angle that we saw. And a possible measurement for the one I just drew could be maybe around 50 degrees. And for naming this angle, we could just call this one angle X. Or if we had some more points on this diagram, we could also call it using the other points. And so our next type of angle are obtuse angles. Obtuse angles are angles that are larger than 90 degrees, but less than 180. And again, it can't be 190 degrees, it has to be greater than 90, otherwise you're talking about right angles. and it has to be less than 180, otherwise that's a different type of angle which we'll talk about later. And an example of an obtuse angle might look a little bit like this. Since it is larger than 90 degrees, notice it is more open than a right angle. And we can go ahead and find a few points on here. And one possible name we could have for this obtuse angle is angle ZXY. And so our last type of angle we're going to explore is a straight angle. And as the name suggests, it's just a straight line. And this type of angle measures exactly 180 degrees. And here, if V is our vertex, then we can go ahead and call this straight angle, angle V. Alright, so now that we know some of the basic types of angles and what they look like, let's get some practice measuring angles using a protractor. And for those of you that have never used a protractor, this is simply a tool that's going to help us measure the amount of degrees in any angle. Now, protractors are fairly simple tools to use, and some of the important parts about them are, for one, this point in the middle here. Some types of protractors have a little hole there instead, but essentially we're going to be using that point to line up with the vertex of the angle that we are measuring. And from that point, we also have the 0 degree line here, and another 0 degree line on the other side, which we would just be using one of those when we measure angles depending on the orientation of the angle that we're going to measure. And so the last thing to notice before we look at an example is that there is always two sets of numbers whenever we're measuring angles. Now, for our measurement, it's only going to use one of them, and the way that we decide which one to use just depends on if we're going to be measuring obtuse or acute angles. So let's go ahead and try out some examples where we're going to use our protractor here to find the measure of the angles. So the first thing you want to make sure of, if I go over to this first example, is when you're using your protractor, you want to line up that center with the vertex. And another thing, notice how my 0 degree line on the protractor overlaps almost perfectly with the side of our angle. And at this point, we can look at the other side of our angle to see that it crosses our numbers at 150 and 30. This is where you have to decide which of the two measurements to use. And for this example, we can clearly see that it is an acute angle, and therefore we're going to go with 30 degrees. Because if you recall, acute angles are always between 0 and 90. So if we take a look at the second example here, one suggestion I have for you is before you pick up your protractor and lay it on top, is just try to think about what type of angle you're working with. And for this second one, hopefully you can see that we're talking about an obtuse angle, so its measurement is going to be greater than 90 degrees. So let's go ahead and try to line up our protractor here. Again, try your best to line up the vertex with the center of your protractor and your 0 degree line with the side of our angle. And at this point you can see that it goes between 30 and 40 as well as between 150 and 140. But since this is an obtuse angle and since this is between 140 and 150, I think a good estimate for this angle is around 145 degrees. And so if we take a look at problem number 3, it says find the measure of angle DBC. Now, from what we've learned previously, angle DBC would be referencing the angle that contains those 3 points. And so really all we care about for now is measuring this angle I've highlighted in blue. And there's definitely many other angles we can find within this diagram, but for now we're going to focus on just measuring angle DBC. And so the first thing you want to ask yourself is, what type of angle is DBC? Hopefully you can agree that we're looking at an acute angle here as well. And so we can go ahead and line up our protractor as best as possible. And it looks like we are looking at about a 70 degree angle. So now that we've learned what the different angles are and how to measure these angles, let's start talking about some of the angle relationships between multiple angles. And the first type of relationship we're going to talk about is what is known as adjacent angles. And so our definition for adjacent angles are just two angles with a common side and a common vertex. So an example of adjacent angles are just two angles that are connected. As the definition states, they are connected with a common vertex, so they share the same beginning point, and they also have a common side, which in this case would be this side in the middle. And so in this diagram, I have this angle here, and I have another angle right here. And notice they are connected with a common vertex and a common side. So if I go ahead and plot and name a few points on this diagram, we can go ahead and say that angle ABD, which is the angle highlighted in yellow, and angle DBC, which would be our green angle, are adjacent angles. And I can go ahead and create another example of adjacent angles. For example, the angles that are formed here, you can see one of them is an acute angle, the other side contains an obtuse angle, but once again, these two share a common vertex and a common side, so therefore that is considered adjacent angles. The next type of relationship we're going to explore are what's called vertical angles. Vertical angles are just pairs of angles that are created when you have intersecting lines. Now, when we're talking about vertical angles, you have to know that vertical angles do not share a common side. They only share a common vertex. So in this diagram, we actually have a couple different pairs of vertical angles, and the first set of them are what you can see highlighted in red. So if I have, for example, a few points on here, A, B, C, D, and E, then I can say that angles ACD and angle BCE are vertical angles. Likewise, if you pay close attention here, on the other side of these angles we formed, we actually have another pair of vertical angles. And so we can also say that angle ACB and angle DCE are vertical angles. So that covers the vocabulary for this section. And here's your high-level questioning. So using the information you know so far, can you find the measurement of the missing angles without using a protractor? So here we're trying to find the measurement of angles A, B, and C. And you're given a little bit of information. So you know this angle right here measures 70 degrees. And if you recall, the little box in the corner here represents a right angle. So we know this angle is 90 degrees. So using your knowledge about the different types of angles and the relationships that we've talked about so far, see if you can figure out what the missing angles are.